So the JVM performs following operations. That is, it loads the codes, verifies the codes, executes the code, and provides runtime environment. So JVM provides definitions for the memory area, class file format, register set, garbage collection heap, fatal error reporting, etc. I don't know these things, sir. I didn't get it exactly. What is that?
Yeah, we'll go through in detail. Okay.
Hmm.
So first one is like a different operation. What it does, it says, okay,
Hmm.
loading code, verifying, executing, and providing runtime
Huh.
environment. That I think
That
you understand.
yes, sir.
So if in my previous discussions, I was telling there are different memory areas,
Hmm.
right? So if you see the diagram, you have that class area, heap, stack, PC register,
PC register,
and
native
native
method
method.
stack.
So these are memory areas.
Hmm.
These are memory areas allocated by JVM.
Hmm.
So different memory areas are there to perform different types of activities.
Okay.
So it is like that. So like in a house, you have kitchen, bedroom, hall room, right? So different areas are there, and different areas, different activities are performed. They are
Hmm.
meant for different works,
Hmm.
different tasks, right? So same,
Yes, sir.
memory has a different parts to perform different activities.
Hmm.
Then class file format. So you have that class file format, that bytecode and all. So
Yes, sir.
that it is about that. Then register set.
Set.
So you have that register memory,
Hmm.
register. So it is related to it.
So this
Garbage collect
PC register, sir.
related to that. Yes,
Okay.
PC register related
Hmm.
to that. And then garbage collected heap. So you have that
Hmm.
heap memory. So
Yeah.
that is where object is created, and when objects are clean, that is what we call as garbage collection. They are removed
Hmm.
from the heap memory. So
Okay.
there are a lot of algorithms and different things to learn and know about heap. So about that we will be knowing fatal error reporting, etc. So when their memory management also fail, right, there would be certain fatal errors. So we need to understand what kind of fatal errors are there, and when those kind of errors come, what are the activities or how to fix them.
Okay.
Actually, you should memorize or remember this architecture diagram. If you
Okay.
remember this diagram, then whenever we are talking about JVM, you should relate to this diagram.
Okay, sir.
Okay, so whenever your class is compiled and bytecode is ready, and you are running a Java program, java.filename,
Hmm.
then this class loader execution starts. First
Okay.
Java runtime environment is created, this entire diagram,
Hmm.
and then Java class loader will load that bytecode class,
Hmm.
and then it will put the respective things in respective memories, and then execution will start. And that you have this execution engine in the bottom left side.
Hmm. Hmm.
That execution engine actually manages all these memories and all the threads activities.
Hmm.
And execution engine basically uses native method interface.
Okay.
Okay, so those are inbuilt in Java runtime environment, which it uses to manage those that program.
Okay, sir.
And this native method interface, where it comes from? It comes from Java native libraries.
Hmm.
So these Java native libraries are the one which are JDK specific. So the Oracle or any other companies or OpenJDK, whatever libraries they prepare. So these Java native libraries are made by them, those companies, and we choose which one we want to use. And this is where
Okay.
all the different types of algorithms and all which we saw in the previous discussion, that they can choose their own algorithm to implement based on the
Hmm.
JDK specification.
Okay,
So
sir.
JDK specification will be same, but using that same specification, different people will use different algorithms and make their own choice how they want to implement those different libraries.
Okay, sir. Hmm. So this is the class loader is a subsystem of JVM which is used to load class files. Whenever we run the Java program, it is loaded first by the class loader. There are three built-in class loaders in Java. So one is Bootstrap class loader, extension class loader, and system application class loader. So Bootstrap is this is the first class loader, which is the super class of extension class loader. It loads the RT-jar file, which contains all class files of Java standard editions like java.lang package classes, java.net package classes, java.utility package, java.io, Java SQL classes, etc. So next one is extension class loader. This is the child class loader of Bootstrap and parent class loader of system class loader. It loads the jar files located inside jar underscore home. So only at this path only we will be getting this one, sir. Hello.
What is the question?
No, my question is this extension class loader they are telling no, sir. This is a child class loader of Bootstrap and parent class loader of system class loader they are saying. So whatever the jar files that are located in this location only, it will be loading.
So basically, you have seen how to customize a class path in the properties file, the command prompt, right?
Hmm.
So those you are setting temporarily or
Hmm.
permanently in your properties file,
Hmm.
property section, right? But instead of that, if you have certain jar file directly put into this folder, ext folder, then it will consider those jar files. You don't have to
Oh.
set separate path for that. So this is the extension class loader where
Hmm.
any jar. Normally we don't put any customized jar file. These are only standard jars only are there.
Okay.
It automatically Java identifies this folder and it picks those related classes.
System application class loader. This is the child class loader of extension class loader. I think it is the parent, right, sir? System.
No, it is child loader. So parent is your bootstrap. After bootstrap,
Then the
there
this
is
one
child.
is wrong, sir. This is the child class loader of Bootstrap and
Yes,
parent class loader of system class loader.
parent
So
of yes. So it is parent of system.
okay, okay. This
Generally,
is the
system is
child
the
of
child.
okay, got it, sir, got it. This is the child class loader of extension class loader. It holds the class files from class path. By default, class path is set to current directory. You can change the class path using hyphen cp or hyphen class path switch. It is also known as application class loader. Can I know what is this changing, sir? You can change the class path.
So you can you have a currently you have let's say some default class path. Okay.
Hmm.
Now you want to add something new path to that. Okay.
Okay.
You want to edit some path when you are going to do your new execution or you want to compile something. So that time you can change the path using the cp command and then add the new path which you want to do want to use.
Okay, that we will be seeing, sir, in our coming classes
Yeah, yeah. So
practically.
yes. So normally, you can try that out. How to change? You can take this one activity. Take write it down.
Yes, sir.
Practice how to set application class path using CP
How to set class path.
class path. Give me 1 minute. हेलो हाँ 10 मिनट दो मैं एक मीटिंग क्लोज कर रहा हूँ 10 मिनट में Yeah. So first one and second one is default.
Hmm.
Okay, you don't have to do anything.
Hmm.
Mostly you need to play with the third one, that is a system or application class loader. So you can explore some YouTube
Okay, sir.
videos,
I'll
uh,
do.
articles and practice.
Okay, sir. This one I am trying, sir. Here the output is coming, but when I am compiling, running this one,
Show me the program.
uh, yes, sir. One sec. These are the error. This is the error I am getting. Maybe, when I searched in Google, it is saying that if you copy
Yeah,
and
I'll
paste
help
here,
you.
this.
Show me the program.
1 second. Oh, ClassLoader. This is the program, sir.
Okay. Public class this, public static void main string. Dot. And show me the error. Show me from the starting. Okay.
This is the starting, sir. This is the starting, sir.
Class loader example. Can you clean it and compile and show me?
Sure. Shall I move up, sir? It's fine.
Go to the top again. Okay. It says illegal character public class loader example class loader dot java illegal character. Okay. Go to the program and show me line number 2.
Any spaces corrections, sir?
See, your class name and file name are different.
ClassLoader on, okay, L I have given as a small letter, right, sir?
That is class loader and this is class loader example.
Okay. I'll correct it, sir.
You can check it later. Move on.
So these are the internal class loaders provided by Java. If you want to create own class loader, you need to extend the class loader class. So second one is class method area. Class method area stores pre-class structures such as the runtime constant pool, field and method data, the code for methods. So next one is heap. It's the runtime data area in which objects are allocated. Stack. Java stack stores frames. It holds local variables and partial results and plays a part in method invocation and return. What does that mean, sir? Stack.
Java stack stores frames. It holds local variables and partial results and plays a part in method invocation and return. So you go back to your diagram. Okay. So when you are creating the class objects in the heap method, okay, and then inside every object, okay, there would be all those variable references.
Okay.
Okay, whatever variables you declare, whatever methods you declare, then when that object or the class code is getting executed line by line, right?
Okay.
For every execution is created as a stack entry. Okay, every line of code or every execution point is a entry in this stack.
Okay.
Okay, so stack is first come last out, right?
Okay.
So
So it is like a temporary memory, sir.
it is also a memory and also it is helping to do the execution.
I mean, like it is only temporarily we will be
Temporarily
using.
only or during the runtime. So this entire thing is temporary only. Only when you are running the program, these all will be allocated Execution
Okay.
will happen. Once execution is done, then everything will be shut down.
Okay.
So in that stack, those variable references and the calls will be entered one by one, and once they are completed, then one by one it will be popped out from that stack.
Mhm. Okay.
Yeah, go ahead.
Program counter register. PC program counter. PC register contains the address of the Java virtual. So native method stack, I didn't get it, sir. What is native method? I don't know.
Yeah, go back to the diagram again.
Hmm. Oh, this one. Okay.
See, you have this native method stack. Okay, and
Hmm.
in the bottom you have execution engine and native method
Fusion
interface,
engine.
right?
Hmm.
So
Hmm.
the class area, heap, and stack are used by all the
Hmm.
methods and objects which are created by your application.
Hmm.
Okay. But
Okay.
what about the references which is I am using from the native method library, Java native library,
Hmm.
which is giving me native method interface. And for that native
Hmm.
method interface, whatever objects will be created or whatever reference memory is required, so that will be there in the native method stack.
Okay. It contains all the native methods used in the application. Execution engine, a virtual processor, interpreter, read bytecode stream, then execute the instructions. Just in time compiler. It is used to improve the performance. JIT compiles parts of the bytecode that have similar functionality at the same time and hence reduces the amount of time needed for compilation. Here, the term compiler refers to a translator from the instruction set of Java virtual machine to the instruction set of a specific CPU.
Whatever
So,
you are seeing in that diagram, whatever processes are happening,
hmm,
then
hmm,
the runtime environment is there.
hmm,
Basically, it is interpreting all the informations, whatever is there, into
okay,
system specific or CPU specific information. That is the
hmm,
zeros and ones.
yeah, okay. Java Native Interface. Java Native Interface is a framework which provides an interface to communicate with other application written in another language like C, C++, assembly, etc. Java uses JNI framework to send output to the console or interact with OS libraries, operating system libraries, right, sir?
So that
Hmm.
JNI libraries, whatever they are written in different languages
Hmm.
like
Hmm.
C and C++.
It will interact with that one
Right.
framework. Next is Java variables. This is the next topic, sir. Now coming
So
to the
let's
Java.
this is a entirely different topics on the application side. So
Hmm.
we will cover it in next session. Okay.
Okay.
So you cover some more topics and then we will continue tomorrow.
Shall I continue with this one, sir, for tomorrow?
Yes, yes.
Is
So other topics you continue to read and prepare the PPT. And if you have
yeah,
any program there, you practice it. Okay.
yeah.
And then from here, we will continue the.
So, shall I read these control statements also? Unicode system operators, keywords, and if possible, I'll go with this one also.
Yeah, at least 3 to 4 you target. Three, you minimum three you target. So
Okay,
what you
sir.
can do is take three, and for that particular topic, even if you
Hmm,
do not have program here in this
hmm,
tutorial, you can
hmm,
search in YouTube or in other articles in Google, and then
hmm.
try to get one or two programs and practice them.
Okay, sir. Hmm.
So three topic you take,
Sure, sir.
and for that each topic you try to do some program
For
practice by
hmm.
searching the program in Google.
Yeah, for yesterday, some I have done its programs also. This one, like narrowing array, widening Java, overflow Java, these are the examples only what I have read yesterday.
While you are explaining some concept, right? You open those programs and try to
Hmm.
explain,
Okay, sir.
so that you will be
Hmm.
fluent with the concept versus real time coding.
Actually, these are for these variables and data flow. Next topic only, sir. For data structures and data types, and for variables, these are the programs I have written.